Hi guys, so this is my newest hovercraft. I started working on it last year but never ended up finishing it. It's not a full-scale person holding hovercraft, it's just RC, but I'm hoping to get it around 60 to 70 miles an hour once it's finished. We got a few special things in this. We got some nice 3D printed covers that protect batteries. They're nice and held down by magnets, which is pretty awesome. Got a few of them, one up front, two in the sides, and one in here for mostly electrical components. We're going to have some ESCs mounted right there for powering two enormous EDFs in the back, which are going to provide the thrust for this hovercraft. We also got two downwards fans. These downwards fans produce the lift for the hovercraft and cause it to kind of hover on the ground. You have two fans spinning in opposite directions to cancel out the angular momentum so it doesn't kind of spin to one side. My last hovercraft, last RC hovercraft, only had one downwards and it kind of tilted to one side when you're driving it, which is kind of annoying. So hopefully having two going in opposite directions will solve that problem. They're pretty nice. We got carbon fiber propellers, carbon fiber mounts, so it's pretty lightweight and should provide plenty of downwards thrust. We also got some nice LEDs going around the whole outside of the hovercraft. Those are going to look pretty awesome. They change all different colors and flash. Can't wait to see that. And we also got a skirt made out of PVC backed polyester. I've used this in some other hovercrafts, and it worked pretty well, so we should see it should work pretty well in this also. It's not finished being sewn yet, but I'll get to that soon. Okay, next I'm going to explain how my EDFs are going to work in the back. I got it drawn up in SolidWorks and printed some parts out, so that should be cool. So a while back I drew up the whole hovercraft in SolidWorks to make it a little bit easier to build. It's not exactly the same as one I've built. The thrust system on this is a little bit outdated, but this is what it's about looking like. We got the two giant EDFs in the back, a gear system down here that turns them. The gear system is now different. I'm going to show you the assembly of that in a second. Now these two plates are going to sandwich the actual 2-inch foam body, because in the actual built hovercraft I have cutouts right here, and then these things slide into them and get compressed by using screws. But now the other drawing I have of the new system is right here. Now I didn't make the whole thing inside SolidWorks. It was not really worth it. Like the EDF would go right here. But we got cables that can now go down the inside of the pipe. It's a much larger 20mm carbon fiber pipe. And then come out to the bottom. So now when this thing turns, I can actually animate this one. The wires will actually be twisting inside the center tube instead of the old hovercraft actually had them coming out and swirling like almost like a spring around the outside of the hovercraft, and did not work well when it's trying to spin 360 degrees. I got a slightly different gear ratio here too than the other one. The other one was doing 180 revolutions on the servo to 720 on the actual EDF section, which was way too much. The servo couldn't handle it. The servo didn't have enough resolution, so I've designed this one to do. This one spins 180 and this one spins around 360. I had to actually take apart this servo to make it spin 180 and put some resistors in there, but it's not that bad if you guys are looking into doing that. It does give you a lot more movement. And then the wires will come out through this little gap right here and spin a lot less. These are a bunch of bearings also I have to make it spin a little bit easier. But yeah, that's the SolidWorks drawings. It's pretty cool. Also, this is not in the actual part. These are, when I 3D print my stuff, I don't have support material, so I usually generate my own in SolidWorks and then break it off afterwards. But yeah, worked pretty well. Now I actually finished 3D printing all of this, so next I'll show you what I've actually made. So here's the mostly completed EDF propulsion system. We got the big, about 100mm EDF here. Can now put almost 2 kilograms, I think, which is just under 5 pounds of thrust, which is pretty intense, and it should propel the hovercraft pretty fast. So this one's a little bit more complicated than the second EDF. This one actually has a gyroscope on it. This gyroscope is going to be controlling the aileron and elevon on the hovercraft to try making it a little more stable. It's going to be doing that by controlling these fins back here, and these should help make the hovercraft a little more stable and make it less likely to flip over. Now this whole assembly can rotate 360 degrees, and all the wires that are coming off this thing travel right down through this pipe and come out the bottom. You can see right here we got our gear ratios connected to the whole servo system that causes the thing to rotate. I kind of showed you that in SolidWorks already though. Now that is going to be threaded through this bottom plate like here, and the wires are going to come out to the bottom of that bearing and be able to spin pretty freely. And again, these two plates are going to be compressed against each other and squish the foam part of the hovercraft to make it pretty stable. But yeah, it's a pretty cool system. SolidWorks helped a lot making it, and hopefully it works pretty well. Looks pretty intense, actually. And this is the older system right here, just a tad bit different gear ratio, but I had to redesign it a lot because it wasn't powerful enough and spun too much. So, and see, it's a much smaller centerpiece, and I couldn't get any cables run down there. And then, like I said before, it used to come around the whole outside like this, and then used to twist and untwist that cable. It's kind of hard to explain, but this design is much better, and hopefully will work much better also. But yeah, there we go. Now I gotta install it in the hovercraft and see if it actually works. So stay tuned for that. So I just finished wiring this whole entire EDF. It was a real pain trying to deal with this many wires in such a confined space. But the good news is it actually works. So we got the spinning, not as much as I wanted, almost 360. Just a little, the servo's a little bit underpowered, but it's not bad. But now we got this guy too. So I finished wiring up both EDFs. They both work very well. You could see it moving a little bit in the time lapse, but not that well. The problem is, though, they draw a lot of current. Both of these servos, since they're under a lot of stress trying to turn these things, and a lot of wires are causing them to need more strength, it's pulling a lot more amps through the battery elimination circuit. And I was running all the components on the hovercraft from one of these little 3 amp or 30 amp ESCs with a 3 amp BEC on it, and that thing got so hot. I'm so surprised it didn't burn out. I couldn't touch it for like 20 minutes. So I happily didn't burn that out, and I tried it with a bigger ESC with a 4 amp BEC, just using it as a BSC, not as actually running anything off of it. And that too got super hot. So instead of buying a bigger one, because I don't think I have any bigger ESCs that can output a more than 5 amps or more than 4 amps for the BEC, I took this one apart a little bit and attached a heatsink to the BEC component on the actual ESC, and it works pretty well. Now it gets a little warm after like 5 minutes of use, but before I was almost burning myself touching it. So this should hopefully work well enough till I have time to buy I'm going to buy a second battery just for powering the receiver and all the components. But that's my little fix I made with hot glue gun and an old heatsink laying around, and it works pretty well. So yeah, there we go. So if you're wondering why I am using two different gyroscopes, this is why. So after visualize it, it's feeding back to itself over and over again, so it flips the heck out and doesn't know what it's doing. So by having one on this to control the flaps on the back, and having one on the actual hovercraft that controls the rudder with these two, you'll get a lot more stability that way, and none of the rapid feedback and making your thing freak out like that. So that's why I'm using two different gyroscopes. This one's a 3-axis, this one's only a 1-axis. So works pretty well though, I think, or it should. I haven't really tried it yet. But yeah, there we go. So I finished the hovercraft about a week ago. I haven't had too much time to test it really. I did test it one time overnight, but I didn't get any good video because it was really dark out. But hopefully this weekend I'll get some good footage of it driving around. Everything worked out pretty well. I got the nice lights on here. Sadly, the lights no longer flash like they did in the video because I accidentally caught the controller on fire that controlled that. But I might try to add it in the future. We'll see. But the wiring didn't really work correctly with my ESCs, so it might not work in the future. We'll see. But everything else works fine. I got the hovercraft skirt all sewed, sewn, set on the bottom. Works pretty well. I added a special tension ring around the bottom that is something new I've tried, and it seems to work pretty well. I got all the EDS working, the gyroscopes, as you can see when I move them, they help to correct the hovercraft. This is it working in the rudder, and then in the back we got upwards and downwards force, if you can see it like that, and if we roll, those two at the end also spin, which is pretty cool. If you get all three, it gets really crazy. It's so cool. But we also have the two downwards fans right here. That worked just fine. And the two back ones. Oh god, this is gonna be. I can't do these full throttle. They're a little scary. Actually, they will. Let's see, ready? They're pretty powerful. But yeah, this thing worked great. When I tested it the other night, it was flying around like crazy. I got better video of it. But again, I'll try it again soon. But I did try it again in daytime, but these things output so much thrust that it started breaking the mountain I had. Also, I kind of crashed into a wall at like 30 miles an hour, which probably isn't good. I mean, I think I actually have video of that, so maybe I'll post that in this video. But yeah, I kind of broke one of the mounts from one of these things, so I'm going to have to redesign that yet again. But besides that, it worked really, really well. I am really, really impressed on how it worked. But yeah, that's about it. Stay tuned for some more video of it flying around. I'll have a video of that posted as soon as I can. But yeah, hope you enjoyed the build. Sorry it was kind of boring, but it was, might as well post it. It's kind of cool. I enjoyed it. But yeah, thanks for watching.